All right, so welcome back. This is week 6, and today we're going to finish chapter 2 or section 2. And we finish that by looking at the reactions of alkanes. Alkanes, with their single bonds, they aren't as reactive as alkenes or alkynes, so we're only going to look at a few reactions here. So first, a definition that is a review of chemistry 1121 or 1120. All right, so a substitution reaction. You guys might have heard this in 1120 as a single displacement reaction. It's a chemical reaction where one functional group in a chemical compound is replaced by something else. Substitution reactions are very important in organic chemistry. So, for example, in this situation with alkanes, when a carbon atom loses a bond to a hydrogen and gains a new bond to a heteroatom, so something like, I don't know, chlorine or oxygen or something like that, we say the compound has been dehydrogenated or oxidized, meaning we've removed a hydrogen atom to form a bond. So combustion is a really simple example of this, and you guys learned about combustion in chemistry 1120. Another very common example is the oxidation of an alcohol to a ketone or an aldehyde. So we use a chemical reaction to reduce this alcohol group into a ketone or an aldehyde. So first one is combustion. The first reaction you need to know is combustion of alkanes. The alkane, with the presence of oxygen and some outside energy, is converted into CO2 and H2O. So here I have methane. The process of converting methane or combusting methane is first it would turn into an alcohol, methanol. Then it would turn into an aldehyde or carboxylic acid. And then finally, it's the most oxidized as CO2. And really, all you guys need to know about this is that alkanes in combustion, so an alkane with oxygen, these are the same formulas, by the way, will produce carbon dioxide and water. So you guys, oh my gosh, are expected to know this. All right, sorry about my pen there, but the idea is combustion of any hydrocarbon will give you carbon dioxide and water. So this example says, write the combustion reaction for pentane. Now, you are expected to know this. Pentane is C5H12. So the combustion reaction for this is C5, sorry about my pen here. And then oxygen. We always add oxygen for a combustion reaction. So C5H12 plus oxygen will give us carbon dioxide and water. Now we have to balance this equation, so I would put 5 carbon dioxides on this side Hydrogens, I would put 6. And then all these together, we're looking at 16 oxygens. So I would put an 8 right here. This is the combustion reaction for pentane. C5H12, so there's 5 carbons and 12 hydrogens. I'm adding that to 16 oxygens, and then over here I get the same number, 5 carbons, 18 hydrogens, and then of course 16 oxygens. So I would love for you guys, I'll pause myself, but to take a minute and to find the combustion reaction for this molecule. Now this molecule is 1, 2, 3, 4, 5, 6. So this is hexane, or C6H14. So I'm going to pause myself, and I would love for you guys to try this reaction to find the combustion reaction. Okay, so let's look at the answer to this molecule. So first things first is I count the carbons. So 1, 2, 3, 4, 5, 6. So the molecule here is C6H14, which is hexane. All right, so C6H12, we add oxygen to this. We get carbon dioxide and water. So let's think about balancing this. And again, this is from Chemistry 1120. So, okay, 6 carbons, so I put a 6 here. Hydrogens, I have 12, so I put a 6 here. And then I add my oxygens together, I have 12 oxygens and 6 oxygens. So I have 18, so I put a 9 right here. Okay, so that's my combustion reaction for this molecule. All right, you can also halogenate or halogenate alkanes. Acyl halides can be prepared by using alkanes as reactants. It involves substitution reaction, where one halogen atom replaces a hydrogen from that molecule. So we call this halogenation. Chlorination and bromination are the most widely used. So meaning we could take a hydrocarbon and react it with chlorine or bromine with a little heat or light. So this means heat or light. And we can replace one of those hydrogens with a chlorine. And yeah, that's basically it for today. Next class, we're going to start with chapter 3, or we're going to get into chapter 3. So I'm going to hit stop record. And if there's any questions, let me know. All right, so have a good day.